Konnichiwa! In this video, we're going to be discussing fractals, which tie together geometry, art, and nature. So a fractal is an object that is self-similar. An object is self-similar if one part of the object can be enlarged to look like the whole object. So in nature, you can see fractals represented by ferns or branches of rivers. And scientists use fractals to map out clouds in order to predict rain. Many fractals are formed by a repetition of a sequence of steps called iteration. The first stage of drawing a fractal is considered stage 0. Helga von Koch described a fractal known as Koch's snowflake, shown in example 1. Alright, so we'll be looking at the example here in a second. There's lots of crazy pictures, psychedelic pictures, that if you were to zoom in on what would be considered, like one of the tails right there, if you were to zoom in, it would actually end up looking like the entire picture itself. Alright, so a history note. Computers made it easier to study mathematical iterations by reducing the time needed to perform calculations, which that just makes sense. As technology develops, these calculations can get quicker and quicker. Using fractals, mathematicians have been able to create better models of coastlines, clouds, and other natural objects. Alright, so here in example 1, this is Koch's snowflake. You start by drawing an equilateral triangle, and that every stage, each side is divided into thirds. So here I could divide each side into thirds, and then in the middle third there is going to be a triangle drawn on each. Alright, so the next one, it ends up looking like the Star of David. Alright, and then you're going to continue to chop each side of every single one of those stars, or those triangles, into thirds, and then you're going to draw a triangle. Alright, so that is after I repeat stage 1. Alright, so now we're at stage 2, and then there's stage 3. Alright, so it keeps going. So this is Koch's snowflake. Alright, measurement. Benoit Mandelbrot was the first mathematician to formalize the idea of fractals when he observed methods used to measure the lengths of coastlines. Coastlines cannot be measured as straight lines because of all of the inlets and rocks. So Mandelbrot used fractals to model coastlines. Alright, so here's example 2. Find the length of the fractal. Find the lengths in a fractal. So make a table to study the lengths of the sides of Koch's snowflake at different stages. So you've got your stage number, your edge length, the number of edges total, and then your perimeter. Alright, so at stage 0, if I go all the way back to, this picture here, at stage 0, I have got a edge length of 1, and there are 3 total edges, 1, 2, 3, and then the perimeter is going to be 3. Alright, so then when I increase by 1 stage, the edge length is going to be 1/3 since I chopped each side into 3, and then I have all of my edges, and they add up to a total of 12. So now I have, each on each side. If I were to go back 1 stage right here, I would count up all the edges. So here's one side of my original triangle. I've got 1, 2, 3, 4. Alright, so that's where the 3 times the 4 comes from, is 3 sides of the original triangle, and now 4 segments for each side. And then they get the perimeter of 4 because I've got 12 times that 1/3. Alright, and then they continue with it to stage 2. I've got an edge length of 1/9, so on and so forth. And then I keep going, and I can keep going, and I kind of recognize the pattern of what's happening. While I keep dividing by 3, which means my denominator keeps increasing by a power of 3. And then I recognize a pattern of what's happening with the number of edges and my perimeter as well. So I can write those all as general expressions with the variable n. Alright, so here are your practice problems. Please feel free to email me with any questions that you have about fractals. I definitely highly recommend actually Googling fractals in nature, and you're probably going to get some pretty cool pictures. Alright, let me know if you have any questions. I look forward to hearing from you guys. Good luck.